This video is about energy losses across a gate valve. For the gate valve experiment, pressure difference before and after gate is measured directly using a pressure gauge. This can then be converted to an equivalent head loss using the equation 1 bar is equals to 10.2 meters of water. This experiment aims to determine the loss factors of flow through a gate valve. The apparatus and supplies needed are a hydraulics bench, an energy losses in vents and fittings apparatus, and a stopwatch. This is the energy loss apparatus. This is the inlet and the long bend. Above it is the area enlargement and the area reduction. On the upper left corner is the short bend. On the upper right corner is the elbow bend, that is the differential pressure gauge and the gate valve fitting. And on the lower right corner is the miter bend. Now let's discuss the procedure. The first trial is opening the gate valve approximately 125% of one turn. For each at least of 5 flow rates, measure pressure drop across the valve using the pressure gauge. Adjust the flow rate by use of the test rig flow control valve. Once measurements have started, do not adjust the gate valve. Afterwards, determine the volume flow rate by timed collection. This is achieved by closing the ball valve and measuring with a stopwatch the time taken to accumulate a known volume of fluid in the tank, which is read from the sight glass. The second trial is opening the gate valve at approximately 100% of one turn. Again, measure the pressure drop across the valve using the pressure gauge. Adjust the flow rate by use of the test rig flow control valve if needed. Determine the second volume flow rate by timed collection. The third trial is opening the gate valve approximately 75% of one turn. Repeat the process done in the first and second trial. By measuring the pressure drop across the valve using the pressure gauge, adjusting the flow rate by use of the test rig flow control valve, and determining the flow rate by timed collection for the third time. This is a sample data and results from one of the groups of the students in the university. They did 3 kinds of number of turns: 125%, 100%, and 75%. The elevation head was kept constant, and so is the volume. The discharge, which is in meter cube per second, varies from every number of turn. It can be seen from the sample data that the velocity is greater when the gate valve is more open. On the other hand, the head loss and its coefficient is higher when the gate valve is more closed. Some probable sources of error in this experiment are mainly just human errors. Human errors are impossible to prevent but may be lessened through conducting the experiment properly. Incorrect reading of measurements is often the mistake during experimentation. These errors occur when eye-level reading is not made. Incorrect interpretation of measurements and an inaccurate number of people doing only a specific task may cause different perspective of interpretation. Besides human errors, another source is the apparatus itself. Since the apparatus does not function completely well, results may be affected by the hindrances. Seeing a mosquito larva in the water tubes, there is a great possibility that the water may contain dirt and may cause cloggage. Could be concluded that the loss factors for flow through a gate valve that was determined through performing the experiment were varying depending on the number of turn percentage. With the data and results gathered, it was observed that the more open the gate valve is, the smaller the difference in pressure and its corresponding head loss and loss coefficient. Some recommendations for future experiments would be conducting more trials for greater accuracy in data, testing with more variations of percentage number of turns, and experimenting with different kinds of pipe systems.